In this lecture, I'll introduce the UIX of bada. In particular, I'll talk about the face detector, recognizer, haptic and motion, sensor manager, and weather items. First, I'm going to give you an overview of UIX. UIX refers to User Interface Extension. It's provided to support more features than a basic UI and enables you to use various sensors, input devices, and output devices. Basically, the most important component is the face component. The face component provides the face detection and face recognition functions. Haptic is a device that gives feedback to users using the vibrator in the phone. Motion refers to the component that provides simplified input to applications from the inputs of various sensors. First, let's have a look at the face detector. Face detection is a feature that extracts a human face from images or videos. When you use this feature, you can specify the maximum number of faces on the screen and the minimum face size depending on the picture resolution. For example, in the case of a 640 by 480 image, if you set the minimum face size to 1, only faces bigger than 26 pixels will be found. If you set it to 2, only faces over 44 pixels will be found. And if you set it to 3, only faces over 88 pixels will be found. Now, let's take a look at the face detection function through an example. To use the face detector function, I've created and constructed the detector and called the detect faces from still image n function of the detector with a bitmap as the parameter. The output is returned in a list containing rectangles. Each of the rectangles refers to the rectangle corresponding to a human face. The face recognizer function is used to get the face recognition info data structure from a picture. The face recognition info is the information containing the face features used to distinguish faces. Now let's take a look at an example to find the same faces from a real picture using the already known face recognition info. This is the find face function that gets the information about a face from a bitmap image and returns true when the same face exists in the image, or returns false when this is not the case. To use the face recognizer, I've created and constructed the face recognizer class. Then, I sent the image to the recognizer by calling the extract face info from still image n function. Then the list of faces in the image will be returned. The list consists of data in the face recognition info structure. Get the pointer of each of them and call the isMatching function of the face recognizer, passing the pre-known face information and this pointer. Then the isMatching functions returns true if the faces are the same, or false if not. Therefore, you can identify whether the desired face is in the image. Haptic is a feature that generates a force feedback effect. Supported force feedback functions include the magnitude sweep and the periodic effect. You can play back an effect that is saved in the IVT file format, and you can play back multiple effects at the same time. You can also get the capability and the current status of the device. To use such haptic APIs in the simulator, you need the TouchSense SDK developed by Immersion. This is an example of using the haptic feature. In this code, we will play haptic using the haptic function. First, to create the haptic effect, I create and construct a haptic object. Then, I connect haptic to the device. Here, device 0 is the default device. Next, the minimum effect interval capability of the device is determined. Then, I create the haptic effect with a periodic effect and set the duration to 5 seconds, the magnitude to 5,000, the style to effect style _ strong, the attack time to 0.25 seconds, the attack level to 10,000, and the fade time to 0.25. After this, we could set the fade level, but I haven't done so in this example. Now, if we pass the periodic effect to the device by calling the periodic effect function of the haptic device, the handle to the current effect is set to the H effect variable. You can stop haptic when required by calling the stop playing effect function, giving the handle as the parameter. After you stop haptic, you have to disconnect from the device by calling the close device function. Now, let's have a look at the motion features. Motion provides functions to get user input in an abstracted high-level form. There are functions that get abstracted input, such as double taps, like when the user touches the device twice, whether the user is shaking the device, using the accelerator of the device, and snap motion, when the user stops while moving the device in one direction quickly. To support these functions, the motion class supports the functions to identify whether a motion is supported by the device or not, and to add listeners to get each of the motions, and to define whether to listen to a specific type of motion or not. Now, let's take a look at the listener object in more detail. The listener object used here is the iMotion Event Listener class. This listener provides the on double tap detected, on shake detected, and on snap detected functions. Now, let's have a look at an example. I created a listener object and added the listener object to the application class. The motion pointer is declared as a member variable, and the 3 functions to perform the role of the listener are declared. Then, I created the motion object in the on-app initializing function of the application and constructed it using the listener. I specified shake and snap as the motion types. Next, I've retrieved the snap motion type from the onSnap detected function of the listener. Then, if the motion type is snap _x _positive or snap _x -negative, the corresponding operation is performed. Finally, in the onShake detected function, the state is returned through the parameter. The state notifies whether the shake motion has been started or finished. In this example, if the shake motion starts, the current time is retrieved, and if the motion ends, and the period of time between the start and end is greater than 1 second, the corresponding operation is performed.